Williams Ecopedia, Volume 1. Topics in Sustainability from Arcology to Xeriscaping. Copyright June 2010. All article text in this book is the intellectual property of William W. Auger. Many of them appear in written form in The Noise and Earth Odyssey magazine and other publications. See their respective websites for their article archives. Published works of the intellectual property right of their respective publishers and cannot be reprinted without their permission. Williams Ecopedia, Volume 1. Topics in Sustainability from Arcology to Xeriscaping. Table of Contents. Eco-Machines, page 52. Eco-Machines. There are many names for this type of system that you may hear. Living machines is the most common usage. The phrase living machine was coined by Dr. John Todd and later adopted by OceanArcs International and later copyrighted by Living Machines Incorporated. OceanArcs now refers to the systems as eco-machines. Under Dr. John Todd's guidance, OceanArcs International has made several successful eco-machines over the last 10 years, as of the writing of this article. For eons, or 5,000 years for you creationists, nature has been cleansing water to pristine drinking levels. In natural systems, this cleansing process occurs in a series of ponds and lakes and streams where anaerobic environments exist in the mud banks. The treated nutrients then flow up into the pond or lake, where the organisms living in the root system of plants further break down the chains. The nutrients then flow through streams and rivers, twist and turn, and tumble over rocks and other formations, aerating the water and then ejecting it into another pond or lake where the process begins again. Exposure of the water to sunlight exposes the pathogens to ultraviolet radiation from the sun, providing natural sterilization. An eco-machine recreates this system of mud banks, ponds, and streams, forming the environment for this process to occur, cleaning water naturally. The Boyne River School in Toronto has a living machine that is the center of the central atrium. Here the machine serves its practical function, cleaning black water from the toilets, as well as functions as an impressive aesthetic presence. When you walk into the central atrium of the school, you see this wonderful water sculpture, says Dr. John Todd. The tanks are 14 feet tall, then spiral down to about 4 feet in a snail spiral. And then you see the water flowing off to a marsh and from there to a pond. The sculpture is the only sewage treatment plant for the school, and it's beautiful. It's a work of art. Continuous testing has shown the cleaned water to be legally drinkable and services all sewage needs for the school of 300. In Las Vegas, Nevada, the Ethel M. Chocolate Factory in Las Vegas, Nevada, uses an eco-machine to process the wastewater from the production of their chocolates, which greatly reduce their sewage bill costs. They also offer daily tours walking through the living machine. The largest and most notable system was built in Burlington, Vermont in 1995. This system cleaned 10% of the city's wastewater, approximately 20,000 gallons a day. In a sustainable design, you must look at the whole water usage of a built structure and the people inside of that structure, and can include many aspects, including eco-machine, gray water systems, wetlands, toilets, sinks, etc. Everything that is the water system of a structure, including the people and plants. For purposes of this discussion, you should no longer think of your house as having plumbing, but as having a hydro system. What we call pipes, stock tanks, and basins in our house to water is no different than streams and ponds in nature. For an eco-machine to work, there must be a few basic design elements present in your system to create the necessary environment. Anaerobic environment. This is done by creating an anaerobe tank, which is simply a tank with an airtight lid. You should place a layer of sharp, porous rocks in the bottom of the tank about 2 to 3 inches, possibly more for larger systems deep. You will also want the volume of the tank to be about 1/3 mud. You can fill the tank with mud from a natural pond or create mud by mixing normal dirt, some sand, and compost. It is preferred for the anaerobic tank to have 2 chambers inside. The chambers can be created by putting a plexiglass sheet or other partition inside of the tank. The partition should have a flow hole near its top. The lid should either snap down into an airtight seal or be coated with RTV or some other caulking substance. Note, if you caulk the lid down, it should be with something that still leaves it easy to open the lid if necessary. The anaerobic tank is then plumbed to another tank so the treated nutrients and water can then flow to the next pond. Be sure that your mud layer will not clog your pipe. Anaerobic tanks can be just simply large drums or such, but I prefer to construct them with smaller chambers inside very, very similar to standard septic tank design. The creation of smaller chambers helps to intensify the environments, thereby speeding up the rate of digestion. Aerobic environment. Aerobic tanks are simply open-top tanks for exposure to oxygen with plants growing in them. Cover the bottom of the tanks in a layer of rocks, the sharper and more porous the better. Then place a few inches of mud in the bottom of the tank. The closer to the anaerobic tank, the deeper the mud layer should be. Plumb the tanks together so that the effluent from the anaerobic tank drops to the bottom of the aerobic tank. To accomplish that, you use an upside-down L pipe. You then create a basket to hang the plants in. The suggested basket design should be made from a wire or plastic cage or mesh. The basket should have a basket depth of 3 inches, deeper in larger systems. Place burlap in the bottom of the basket, fill the basket with soil. Place another wire or mesh across the top of the basket. This will help to keep your plants upright and hold the soil into the basket. Plumb your aerobic tanks with an upside-down L pipe. This will move particulates settling to the bottom of the tank into the next tank, where they will flow through the root systems, where they can be further digested by the micro-inhabitants of that root system. Your aerobic environments must be seeded with plants. Inevitably, people ask, what types of plants? This is the most often asked question of eco-machine design, and the answer is simpler than most people expect. Biodiversity is the strength of any eco-machine, constructed or natural. Hydroecologies require aquatic root plants. That is the main factor. As the constructor and caretaker of the eco-machine, your role is to inject as much biodiversity as possible into the system. Acquire as many varied aquatic root plants indigenous to your area as you can and seed the hydroecology with them. The natural processes of your eco-machine will determine which plants will prosper and which will not. Even if the conditions change in your system, leftover seeds and bits of roots can suddenly flourish. As long as you've provided enough biodiversity of aquatic root plants, your hydroecology can manage itself. You will have to assist with pruning and sometimes thinning out your system to prevent root blockage of plumbing. It's not a bad idea to randomly seed new plants or mud as time goes on. Even if your system is healthy and the ecology is strong, biodiversity is strength. The return stream. As stated above, flow is extremely important to the proper functioning of a living machine. In nature, systems keep flowing due to the hydrocycle. Water rains down from the sky onto the land, coagulates into ponds, which flow over and create streams. The streams then gather into rivers. The rivers take the water down into aquifers or into the ocean. The water then evaporates into the air to form clouds. The clouds then hit cold pockets and rain down onto the land, starting the system all over again. This is a closed flowing loop. An eco-machine must also have a closed flowing loop to keep the water moving. The constructed eco-machine should include a pipe that takes the water upstream. This will always keep the water in your system moving. I make a distinction between inert pipes and ecologically active pipes. Inert pipes are standard plumbing pipes. They are enclosed and the water flows through them. The water inside of the pipe is only moving and not ecologically active. As the tanks are simulations of naturally occurring ponds, an ecologically active pipe is a simulation of a flowing stream, a vital component of the ecology. From here on in, we will refer to the ecologically active pipe as an artificial stream. Whenever possible, in a constructed eco-machine, you should try to create an artificial stream. This will contribute to the overall efficiency of the machine. To create an artificial stream, your pipe must first be open to the air. Using a simple gutter is the easiest for this. Then place a layer of gravel or stones in the pipe. The stones help to act as scrubbers, breaking particles apart as the water tumbles over the rough texture of the stones. The rougher the texture of the stones for this, the better. Volcanic rocks are the best. In larger artificial streams, you can place plants that occur in flowing systems or even things like river clams and such. If possible, in the design, it would be good for the artificial stream to curve several times, though a straight stream will still be effective. Aeration. Aerobic environments, of course, require oxygen. In most natural systems, oxygen is the limiting factor to the metabolic efficiency of the organisms. By providing the system with a surplus of oxygen, you ensure the organisms are running at their full metabolic efficiency. In larger systems, you may want to place artificial aeration systems into the tank, small air pumps to inject air into the bottom of the tanks. Another way to aerate your system is to create fountains and/or small waterfalls. These features will provide even more aeration if they tumble over stones. Also, it is suggested that the artificial stream exit over a small rocky waterfall into your first aerobic tank. Effluent. By use of the artificial stream, the eco machine continuously circulates its water in a closed-loop system. However, the system will eventually fill up and overflow. The water that comes out of it is called the effluent. You must now decide what the effluent is used for and where it goes. In larger systems, it is recommended that your effluent goes through a scrubber tank before leaving the system. A scrubber is simply a tank filled with rocks and sand. It does not have to be as large as any of your other tanks. What you do with the effluent should depend on what type of water you are processing. Hard black water should never be used for irrigation or injected into a natural water source. Black water should either percolate back into the ground, away from any crops or gardens with edibles, or eject into a shallow concrete evaporation pond. Hard black water or gray water should be safe for irrigation of gardens hard black water or gray water should be safe for irrigation of gardens or to dump back into a natural nearby water source. No, I'm sorry, I got that wrong. Gray water should be safe for irrigation of gardens or to dump back into a natural and nearby water source. Gray water can, of course, also be ejected to percolate back into the ground or into an evaporation pond. As I said earlier, black water should never be used for irrigation of gardens or dumped back into a natural system. Ejecta systems can be something as simple as a pipe out of the machine, or preferably an artificial stream or perhaps a pump attached to an irrigation line, even if just being sent to an evaporation pond or back into the ground. Macroorganisms and volunteers. Eco machines can house macroorganisms such as fish, snails, and frogs. Seeding them can be very tricky and potentially cruel to the organism if your constructed eco machine is not yet ready to support them. It is not suggested to seed your hydroecology with macroorganisms, fish or snails and such. You would only inject macroorganisms well after your system has established itself and the plants are growing healthy and the water is cleaned. If your system is healthy, it may very well attract volunteers, plants and animals you did not seed. Volunteers in your hydroecology should be celebrated, as the presence of volunteers shows that your system is an attractive ecology for these animals and plants to migrate to. One system I worked on even developed volunteer fish. Most likely there were eggs in some mud I seeded the system with, and the ecology was healthy enough for those eggs to hatch and the fish to grow. Aesthetics. Many may consider aesthetics not an important part of eco-machine design and construction. I, however, seriously discontend that notion. Aesthetics is of great value. To quote Dr. Paulo Soleri, water as a resource is used and consumed, water as a resource is used and not consumed. Therefore, we plan at Arcosani to use the water in 3 successive steps: domestically, aesthetically, and agriculturally. Constructed hydroecologies with their lush green plants, ponds, and trickling waters are inherently aesthetic phenomena. First off, hydroecologies do not smell. When you mention gray water recycling, most people first think of the smell generated by gray water systems. There are many different designs of efficient and clean gray water systems, but they are not the same as a constructed eco machine. Most gray water systems generate odor because they lack the elements of biological and physical activity that in an eco machine diffuse and clean the exhale of anaerobic activity. Often when you see eco machines, they are in large transparent tanks. All constructed hydroecologies do not need to have so industrial an appearance. Most of these types of systems that you see were purposely designed to be demonstration models of the concept. When constructing an eco machine for actual use, the aesthetics of the design should be considered of high importance. The containers for them can be constructed of anything that will hold water. The tanks could be made from prefabricated plastic containers. These containers could be sunk below grade so as to be unnoticeable, or perhaps the industrial look provides an aesthetic some may find appealing. The ground around the eco machine could be sculpted to aesthetically complement the design of the tanks and artificial streams. With some careful design, it is possible that the constructed eco machine could aesthetically blend perfectly into the existing local natural environment and appear only as landscaping. If inside, the eco machine could be used to create an interior aesthetic environment similar to a solarium. The aesthetic effect and design of an eco machine is limited only by the imagination of the designer and the skill of the builder. Hydroecologies can be aesthetically incorporated into structures in the same way as gardens or fish ponds, or they can even be constructed inside of structures, serving as the centerpiece of atriums or filling solariums or sunrooms. Hydroecologies are natural to be incorporated into greenhouses. Aside from the visual aesthetics, they generate an olfactory aesthetic as they fill the area with the scent of lush growing things. If a hydroecology uses fountain or waterfall elements, the trickling water sound also generates a nice auditory aesthetic. When constructing an eco-machine, all of the visual, olfactory, and auditory aesthetic factors should be considered in the site selection and in the final design. Flow is extremely important to the proper and efficient functioning of the engineered ecology. In stagnant water, aerobic organisms eat all of the nutrients in their available area. Without flow to bring new nutrients in, they will deplete their local area of nutrients and then die. As the aerobes decompose, an environment for anaerobic organisms will be created and they will thrive. Soon your tank will turn into a bog, which will be smelly and not break down nutrients far enough for aerobes to survive. Your engineered ecology will degenerate into a smelly goo. You must design the plumbing of your tanks to create the longest lines of flow to ensure the most efficiency of the aerobic environments. The plumbing of the tank should allow for backflow, that is, for water to move either direction through the machine. This allows microorganisms to move back and forth freely between the tanks. This way, the microorganisms can migrate to whichever tank is the best suited for their nutritional needs. When discussing the constructed eco-machine, it is a tip to refer to downstream from the anaerobic to the last aerobic tank and upstream from the last aerobic tank back towards the anaerobic tank. Care and feeding of your eco-machine. Anyone who considers themselves the stewards of an ecosystem understand that while ecosystems are self-sustaining, they must still be observed and occasionally helped. The constructed eco-machine is an artificial ecosystem, but an ecosystem nonetheless, one that needs stewardship. First off, the simpler your mechanisms, the easier the long-term maintenance of the machine will be. Hydroecology should be constructed with as little machine element as possible. It is advisable that most of the water flow comes from gravity feed. You will need to design your tanks so that they all contain a level water surface. The tank should be below the level of your initial effluent source. This way, the water flows into the system and through gravity flows through the rest of the system without the need for multiple pumps. If you are discharging the water, you could design a gravity feed from the tanks. A pump will inevitably be necessary for the return stream to artificially generate the direction of the flow, and a pump may ultimately be necessary for discharge or other usage. All in all, try to keep the usage of pumps to a minimum and design as much gravity feed as possible. If the machine is seeded with a great biodiversity, the living systems will require low maintenance also. However, death is the natural cycle of all life. Dead materials should be cleaned and removed from the system whenever they are found. However, you can feed them back into the machine, putting them in the anaerobic tank where they will begin to break down into nutrients. Out-of-control plant growth can choke a system, clogging pipes and pumps, choking out other plants, and reducing aeration. The machine's plant life should be pruned and kept in check just as if one were tending a garden. It is recommended that you occasionally inject new biodiversity into the machine. Every once in a while, throw a chunk of compost in, or add a new plant, spit in it, etc. These occasional additions will help keep the engineered ecology robust and evolving. Once you have an eco-machine, I think you'll find yourself giving it a quick glance each time you pass by it. This will be enough to notice most, if any, problems. About every 2 weeks or so, you should just give it a cursory inspection to see how it's doing and if there are any changes or evolution to the system. About once a month, you should give the eco-machine a better inspection. Give all the tanks a good sniff, make sure the return stream is stable, change the pump filters, remove any dead plant matter, and test the water. You should keep a simple running journal noting the results of your inspections, any changes you have noticed in the system, and any repairs or modifications you have made. Too many plants can cause problems with the eco-machine by either clogging the pipes, crowding each other, or reducing the aeration reaching into the water. When the plants get too overgrown, you should prune them back, snip them down, pull a few out, and remove any dead plants. Any dead plants or clippings should be chopped up and put into the anaerobic tank, where they can be digested into your system, recreating the death consumption cycle of natural hydroecologies. It is advisable to occasionally inject new biodiversity into the system. If you're ever out and about and notice or find aquatic root plants, you should grab a small sampling of them, 3 or 4 specimens, and seed them into your system when you get home. Warning: if your eco machine is outside, before the winter hits, you need to cover it in a small greenhouse structure or cold frame, or else the plants will die off when the water first ices over. As late fall approaches, pay attention to the weather forecast and stay ahead of the winter cold snap. Appropriate usage. Eco machines have been successfully used to clean large volumes of water from various industrial and institutional facilities such as the Boyne River School, Effluent Chocolate Factory, in the city of South Burlington, Vermont. These applications have shown that eco machines can be used for the cleansing and in some cases recycling of almost any water usage. It would have to be determined on a case-by-case basis if the entire water output should be handled by one large system, or if smaller eco machines could be constructed for each specific appliance or application. If your goal is just gray water discharge, then an eco machine may be a bit of an over-design unless you wish to use one for philosophical reason or ecological responsibility. Even though results from some eco machines have shown that water can be cleaned to fully drinkable standards, it is probably inadvisable to recycle water into your drinking supply. However, the other recycling applications could all be used to greatly reduce the water consumption of a structure or to stretch the usage from a limited supply of water. A properly functioning constructed eco machine should provide water clean enough to be used on edible crops. In this way, the water ejected from the structure can be used to grow crops to feed the inhabitants of that structure. In households, eco machines can be integrated into a myriad of existing water systems. Some potential household uses include recycling washing machine water, recycling toilet water, recycled bathing water, recycling water used for household cleaning, using water from kitchen and bathroom sinks for irrigation. The use and design of an eco machine should be determined on a site-specific case-by-case basis. One should first determine exactly what it is they wish to accomplish with their water usage, which water systems an eco machine is appropriate for, and determine if the water recycling or water discharge is their goal. From these factors, one can then decide if a constructed eco machine is in fact desirable and appropriate, or if any other pre-existing water systems, such as a gray water system or constructed wetland, are more desirable. In places where available land area is a factor, an eco machine may be preferable over a constructed wetland. By the use of a little bit of artifice, the eco machine has a higher metabolic rate and hence a higher efficiency than a wetland, and therefore it takes up less surface area. Structures that exist in built-up areas may not have enough available area to retrofit a wetland, but they may very well be able to fit an eco machine. Even in structures that have available surrounding land area, the lower surface area of the eco machine can accomplish the same task as a constructed wetland, but leave more area for other usage such as recreation, agriculture, animal herding, or natural preservation. To learn more about how to design and construct an eco machine, you should contact Ocean Arcs International. Thank you.